But so this is the early days in the biochemistry department. So this is it was called the biochemistry department and discussion group. What did they call it? Yes, about 1960. And so this is Govind Khurana here
Oh,
and also
excellent.
Mike Smith here, along with some other members of the department. These are the heads of the department, or at least Marvin Dark was head of the department. Um, Bill Paul. So these are just pictures of the, I told some stories about these people, but so Bill was head when I was, I joined about 1978, something like that. So
Wow.
so it's going way back. I took over Sid Zabarsky's lab.
Hmm.
Sid, he started off Life Labs.
Yeah, yeah. I've
Yeah.
heard his son give a couple of talks
Oh
at
yeah,
different
right.
events. Yeah.
Yeah, the Christmas parties,
Mhm.
and then there was Dennis Vance, who's now he's now at University of Alberta. He's been there for some time. He's retired, but and then Phil Bragg, of course, after him. Mike Smith, Nobel laureates. And so this is these are good slides to show if you want to do
Yeah, for
something.
sure. This is excellent. Thank you.
Um, and then George Mackey, so in the early days, and when he was head of the department. I don't know what's happened to George. I know he got cancer a little while ago. I don't know how
He's
he's.
he's still around. I'm actually gonna also be interviewing him. He still lives nearby the campus, actually.
Yeah, right, right. And he lives just over on 16th. Roger Brownsey. There was a short period where a guy named Chris Proud was, but he left pretty quickly.
Mhm.
Leonard, in 2022, when I gave this, Leonard Foster was head of the department. And so I just said, okay, we're the best in Canada. Um, then the rest of this is just things that I had some fun with. So this is me and this is not so germane to the department, but
But still, no, it's your history as well. So
yeah. So anyway, going through it all. Yeah, so I got the biggest grant the department ever had after buying NMR machines. This is way back. Um, and my wife, lots of papers, but it's like a few little criticisms. This is all fun stuff, right? So
hmm
this is what referees like to do. They make these various statements. And so we invented I've done a lot of work in companies, and so we invented a device called the extruder. This was and four postdocs in my lab in '85, and so we formed we invented this as a device to make lipid nanoparticles anyway. So we formed a company called Lipex to sell this thing, and that was it really managed to enable us to keep a team together, and so that's led to a whole bunch of startups and six approved drugs, and it's been quite a ride actually in the last few years.
oh, for sure. Yeah, you've the amount of work you've put in and the amount of companies that I know I've even interacted with since I've been here that you've had, part of is just amazing.
Yeah, it's been quite, as I say, some of it's not. This is just indicating the drugs that have come along. And also the Pfizer BioNTech COVID vaccine. So I was just emphasizing here why I won that award. That's all.
Hmm
So basic science. Oh yeah, the department hasn't paid my salary all that much, but separate issue. Um, so I guess that's about it. Oh yeah, we had a mission statement for LIPEX. So it was a good one.
Oh, free beer every Friday. That'll do.
Yeah. So sales, ballet. Anyway, Anyway, so I'll send you a copy of this if you
Oh yeah,
want.
thank you. That would be excellent. Yeah, there's I think that's a lot of good information in there that we would love to be able to use.
Okay. Could you send, I don't know if I have your email, but could you send me a note asking me for it?
Sure, I'll send a note.
Okay.
Okay. Thank you for walking me through that. That was a great presentation. I wish I would have been there to see it in person.
Oh yeah, we had some fun, so yeah.
Okay, so I mean, you kind of walked me through this, but just for for interview purposes, I'll sort of ask some of the questions that I have here in regards to the
Sure.
question
Yeah.
bank. Um, so, what is your relationship with the B&B department here, and like how did that relationship arise and evolve?
Oh, I was doing a postdoc in Oxford, and the yeah, I was asked to interview at University of Nebraska in Omaha, and so I looked at that on the map, and it's right smack in the middle of the continent, and I realized I'm originally from Vancouver, so I thought I don't really want to go there, and and so. There was I got a MRC, I applied for an MRC scholarship, which paid for, would pay for 5 years of salary. And in the biochemistry department, I was in the biochemistry department in Oxford. Even though my PhD was in physics, I
Hmm.
switched from physics into biochemistry. I was using, I mean, I knew a fair bit about NMR, so I was using NMR in,
So you're
plasma.
like on that line, sort of, yeah.
Yeah. Anyway, so and because the department didn't have to pay my salary, they said sure. So and so that was really the start of it. The so anyway, that's basically how I got hired. Yeah,
And that was in
1978.
1978. Yeah. Wow, that's and how would you say like the do you think the department has changed from like 1978 to now?
Oh,
If you've
it's
been there.
not really recognizable anymore. It's obviously the whole field has changed quite
For
dramatically.
sure, yeah.
When I was interviewing, Mike Smith. He was doing a postdoc, or not a postdoc, but a sabbatical in Cambridge with Sanger, and so I attended a seminar of his. I mean, this was the sequence, and he was sequencing a phage.
Hmm.
It's 5X174. I don't know how many bases it has, but we'll say 500. And so it was and that was a major achievement at that
Yeah.
time. So that's some indication of how much things have changed.
And what about some of your work? Like, what did you start out doing in the department, and how has that sort of evolved to now?
Oh, yeah, I was doing fairly basic stuff. The Just trying to understand roles of lipids in membranes. And to do that, we had to, membranes are very complicated. I mean, they've got, thousands of, hundreds of different, probably thousands
Yeah.
of different lipid components, proteins, and everything else. And so, in order to study the properties and make some sense of it, you have to use model membranes.
Hmm.
So that's and so that's where you extract the lipids from a biological membrane, and then you make these, small vesicles that consist of those lipids. And so from those, you can start to tell some, basic properties of, what various lipids and membranes are doing. And so one of the properties we were looking at was something called lipid polymorphism.
Hmm.
Over 50% of the lipids in a biological membrane, if you extract them and put them in water, they don't adopt a bilayer, they adopt other structures. And so we related that back to membrane fusion and or ability of membranes to fuse, et cetera. But so that was a part of we had some other basic things going on as well. But the interesting thing was we had these little model membranes, little vesicles, and there was interest in using them as drug delivery systems. I mean, cancer drugs go everywhere in your body. Well, let's package them up and send them more specifically to, say, a tumor. And so I got pretty interested in that. And this was in the early 80s. And so we devised a method for encapsulating cancer drugs in these liposomes very efficiently, and also making these liposomal systems in a very reproducible manner. And so that led to the potential for, as I say, they're using them to target tumors. And so we started a company called Inex. This was back about 1990, and the with the intent actually we got two drugs approved by the FDA taking these were, but also we had to start companies in order to do that. You can't raise that kind of money in academia. Um, I went to my department head in the early 90s to say that I started this company, and it's called Inex, and I asked if I could go on half time, and then the department head at that time, I think it was Paul Glass, but the of course, he wanted to save money, and so he said, "Fine, I'm going to pay half your salary. That's good with me." That really helped because then I could work half time in the company and half time at the GBC. Anyway, so about 95 or so, we couldn't, it was tough raising money to put these old cancer drugs in liposomes, and it's always tough raising money no matter what. But anyway, we decided, okay, well, let's go for nucleic acid-based drugs,
Hmm.
see if we can deliver them. And so that, that's what's evolved into all the work we've done, that led to the vaccine and also to another approved drug called Onpattro.
Yeah, it's tremendous work, honestly. Like it's amazing when you go through your your publications or the companies that you've been with. It's uh, you know humbling to see, to say the least.
Oh, it's
Uh,
there's been a lot of I've had good luck in get attracting some pretty good people to work with me. So that's the big trick in all of this.
mhm. Uh, yeah, speaking of Nova Scotia, Madeline in your lab, also from Nova Scotia. We knew each other at Dal.
Oh, did you? Oh,
Yeah.
okay. Yeah, no, Madeline's doing very well here. Yeah,
Hmm.
yeah.
So with all of that, these huge contributions and everything, what do you think would be like one of your proudest contributions to the department since you've been here?
To the department per se, I mean, well, we've obviously pulled our weight in terms of the research of the department.
Hmm.
Um, the I mean, I've done a few other things. I started off centers of excellence. One of them was a Center for Drug Research and Development, which we started in 2005, and also the Nanomedicine Innovation Network. So these are centers of excellence, pan-Canadian, but I think we brought a lot of attention to the department as being fairly innovative area. So yeah, it's been I think it's a mutually what's the word
Beneficial, yeah.
advantageous situation. So certainly the partners be good to me in the sense, it's like allowing me to go half time on doing some working companies, and also just facilitating, some of the other things that I've done, like starting other companies. So
Hmm.
and that's partly the UILO as well. That's been quite helpful in most ways. So,
Excellent. Yeah, and so what do you think would be, some of like this would be more sentimental, I guess, but the fondest memories you've had like with the department over your time?
Oh, well, I mean, obviously the big thing was, kind of way back when we had a small group, and
Hmm.
we discovered a few things like how to load these drugs into liposomes, and how to make them, and then getting some of these commercial things going. I talked about lipix
Yeah.
membranes. Well, this was me and four postdocs, right? And okay, that's why I say the thing like the mission statement, free beer every Friday and parties are never possible.
Yeah,
Well, that was kind of where our heads were at that point. It was having a good time. Anyway, so that those were great times for sure.
yeah. No, that
But
sounds.
more recently, of course, I mean, with the companies doing what they did, and particularly with the cancer, with the whole vaccine
Mhm.
situation, that's really turned into like a much bigger thing. That's for sure.
Oh yeah, no, it's huge worldwide. I mean, at this point, I think like UBC's on the map for just sort of lipid nanoparticle research, and huge part because of what you've been doing here. So we talked a little bit about how the department has changed over the years in terms of like the research you've done and everything else. But how was there anything you think the department has been remarkably consistent with?
Well, it's consistently very good in terms of getting, getting the faculty in. Up until 2004, we were in a separate building. We weren't in the LSI.
Hmm.
And that was actually kind of fun, because we were all together as one department. It's got a little diffuse over the last, 20 years.
Hmm.
Much part of a much bigger thing, in the LSI. So that's detracted a bit from the sense of camaraderie that we used to have. But I think for students and so on, it's probably an advantage to be, part of something that is much bigger. So there's it's getting harder and harder to get the department together in
Yeah, for sure.
these more social events. I mean, there's a lot of collaboration that goes on, but it's lost a bit of its identity as a result of the move into the LSI. I'm not saying that's a bad thing, but it is something
Yeah,
that's.
it's just an observation. Yeah, I know. So I'm in Thibault Mayor's lab, and so I work in the MSL. And yeah, sometimes it's like, oh, the MSL and between the MSL and the LSI, it's like I barely make it over there and for special occasions, and people from the LSI barely make it over to the MSL
Yeah.
for occasions as well.
Yeah, so we do need to keep up that, this is the job of the department head is not an easy one.
Hmm.
But that's
Sure.
one thing that I know, the Jorg is trying to do. So,
Yeah, and let's see, what else would I have to ask you here? So I feel like we've kind of like touched on this already, but what legacy do you think like the department has created for itself? I mean, in terms of.
yeah, I mean, obviously very strong on the molecular biology side, and so that's and obviously that's a big one. I've been pushing that, obviously lipid nanoparticles, and I said that enables gene therapy in a fundamental way. So, the two things mesh together really quite well. So it's a but I think moving into the therapeutic area now is something that as basic scientists that we can do. I mean, you discover a mutation in a protein that has something to do with cancer or whatever. You can almost instantaneously translate that into therapeutic potential these days with delivery systems like the LNP systems. So that's I think if we can get into that legacy of being part of of the translational medicine. That's what I'm trying to push for right now. I mean, for example, we got a big grant for pandemic response vaccines, about a year and a half ago, and I don't know if there's going to be another pandemic or not. In any way, it's arguable that we would be the ones that would be providing the vaccine. That would be a big company that has that kind of horsepower. But so we've managed to turn it around a little bit so that we're saying, okay, well, the cancer vaccine area where you essentially do a biopsy on a patient, identify mutations, and then identify the neoantigens that might result from those mutations. Say a peptide, 15 or 20 amino acids, and then code for them in an mRNA, and then administer that as a vaccine, so IM or IV, and the results that are coming in now in that area are spectacular. You know, there's 50%
Yeah.
response rates for almost cures for pancreatic cancer and metastatic disease. So it looks like we're on the verge of curing metastatic cancer, and so which is a huge thing. So that's
Absolutely.
where maybe that's where we're starting to focus those efforts. And of course, that really means we're in very direct contact with the clinicians of the Cancer Agency and across Canada, and elsewhere. So I think that's where, if we haven't got that legacy yet, that's where I'm trying to push it.
Yeah, that's excellent. Because I mean, one of the questions I had was, like, what do you think should be the focus for the next
Yeah.
25 years for the department? And I think you kind of just answered it spot on right there.
Yeah. No, that's where I think we have the potential for making some really big contributions. So, it's just a lot of fun when you actually can see some tangible therapeutic benefit to the work you do in the lab. So,
No, that's excellent. So I think, I just have, like one more question, just trying to keep everything, quick for you. I know you're a very busy person. So, um, what do you think? Would you have any like message that you would like to give, like future members of the department, any current or future members of the department, uh,
yeah,
for,
sure. I mean, I think one of the things I've tried to do. Through the years when I'm teaching courses and so on, is to emphasize to students that, I mean, it's changing now, but up until quite recently, you get a PhD, somebody in a PhD program, and they're kind of focused on getting an academic, a position, and that's rather difficult. I mean, only 10%. The number of academic positions is not expanding.
no.
And we produce 10 times more than we actually need for, say, academic positions. And so, but the pointing out all the other things that they can do, whether it's in industry or whether it's in, legal stuff or when, regulatory health, there's just a gazillion different opportunities. So you never regret getting an advanced degree in biochemistry. It's a great degree because it just allows you to do all kinds of other things. So.
So you just say like, basically keep your options open, for
Oh, absolutely,
students.
and they then don't get too locked into saying I want to be a prof, because
hmm
that's a it's not just a tough thing to do. There may be other areas that are more fun to do. So
Yeah, absolutely. I have quite a few friends who have gotten their PhDs in the last few years, and I don't know anyone who has made it broken into academia yet. But
yeah.
what would you have anything like for maybe the the younger profs or something in the department who have made it, or would you have any advice for them as well?
Oh yeah. No, that's yeah. Younger members of the department, this is a general thing, but life is tough. The getting grants and all the rest of it, it doesn't get any easier. If you're south of the border right now, it's murder.
Oh
Uh,
yeah, it's crazy.
so that's a so you got to broaden you can't go straight for. I mean, that's where some of the applied stuff, maybe it's a little better grant situation than it is in for straight basic science stuff. But that's not to say that if you don't do the basic science, you're never gonna you don't have much to contribute when it comes to okay, well, how do we improve some therapeutic? I mean, if you have to have some pretty very deep knowledge, and that's what comes with getting a PhD and doing some basic research. I would never have been able to do anything on vaccines or whatever unless we'd spend 20 years trying to understand what the hell lipids were doing in membranes. That's so it's an interesting combination. You got to keep the basic research going.
Yeah, absolutely. Yeah, well, I think that's pretty much all I have to ask. Yeah, thank you so much for taking the time to speak with me, and I'll send you a note or an email to so maybe you can, if you want to, we're able to send those slides over. Those would be a huge help as well.